Hello everyone! I know I promised you guys to film a video regarding all the material that was going to be on the test, but I was filming that video and noticed that it was getting incredibly vague because I had to cover all the chapters in under 10 minutes. And in the end, it wouldn't have been beneficial for you guys because it didn't cover anything. So I decided not to film that video, and we can discuss on the next essay session all the material that you didn't quite understand from the previous test, and we can also finish discussing chapter 15. So as I mentioned on this video, we are gonna be looking at the senses that are related to the ear, so both hearing and balance. So you can find this picture on page 587 of your book, and I found it very useful in explaining how the sound waves travel through our ears. So you can see the sound waves are vibrating the tympanic membrane on step 1, which causes step 2 to happen, in which the auditory ossicles vibrate and transfer this vibration from the tympanic membrane into the oval window. And the pressure exerted on the oval window is actually 20 times greater than that of the tympanic membrane, meaning that the vibration of the ossicles into the oval window actually amplify the wave. And as they vibrate into the oval window, they cause pressure waves in the water that's filling the vestibule and cochlea. So in step 3, there are pressure waves that enter the vestibule, and then these waves can travel through 2 pathways down the cochlea, either 4A or 4B. In 4A, will be followed by very low frequencies, usually below 20 hertz. And these frequencies we are not able to hear because they're so low, meaning that they do not activate the spiral organ. The other pathway is 4B, and this is gonna be followed by frequencies higher than 20 hertz. And these frequencies are going to actually activate the spiral organ. This next picture you can find on page 584 of your book, and it represents the location and structures of the spiral organ. So you can find the spiral organ within the cochlea on top of the basilar membrane that divides the scala tympani from the cochlear duct. So basically, continuing on what I was saying before, the pressure waves have entered the oval window and they are traveling now through the scala vestibuli. As you can see, it's the top compartment. Then these waves are going to vibrate on the vestibular membrane, which causes the waves to enter the cochlear duct. And as these waves enter the cochlear duct, they're going to hit the tectorial membrane that you can see on the right. It kind of looks like a blue wave. And this membrane is going to start vibrating up and down. And it's going to hit the hair cells that are going to be our receptors. So the hair cells are called hair cells because they have cilia projecting upwards that looks like hair. And when the tectorial membrane vibrates up and down, it's going to bend these cilia. And that's what's going to cause the action potential to fire and go down through the cochlear nerve. So the way you can tell high pitch from low pitch, it depends on which area of the cochlea the pressure waves enter the cochlear duct. So basically what you need to know is that as the frequency gets lower, meaning the pitch also gets lower, the further down the cochlea is going to travel, and it's going to activate spiral organs that are further down the cochlea. While you have a higher pitch, it's going to travel less further, so it's going to travel closer to the base. And it's going to enter the cochlear duct sooner. And the higher the pitch, the closer it's going to hit. Also, in case you are still confused, low frequency means low pitch and high frequency is high pitch. And low means going further in, high means not going as far in. Now, moving on into balance, this picture is on page 591 of your book, and it shows you where the location of the macula is and also its basic structure. Now, Dr. Witt will explain to you that there is 2 types of balance. There's static balance, and then there is the dynamic balance. So the macula is mostly used for your static balance. The way it works is that when you tilt your head side to side, the otolith membrane is going to move to one side or the other, bending the cilia on the hair cells and activating them, sending action potentials down the vestibular nerves. Also, if you were standing upright without leaning to one side or the other, then the gravity will simply just pull the otolith membrane down and you wouldn't be bending any hair cells, therefore you're not sending any action potentials. However, if you think about the way this works, it makes sense that it is also how you feel linear acceleration. So our bodies can't feel velocity when it is constant. It can only feel the changes in velocity which are caused by acceleration. So for example, if you're sitting in the car after a stoplight, when you start accelerating your car, you're going to feel yourself shift backwards. And at the same time, this otolith membrane will also shift backwards, and you're going to feel this change in your equilibrium. So before we move into rotational and dynamic balance, I want you to understand where the receptors for this are going to be, since it's kind of important in understanding how they work. So you can find this picture on page 583 of your book, and you can see kind of like on the top left, the big semicircular canals. And at the base of these semicircular canals, you can see the crista ampullaris. They're these little purple drawings, and these are going to represent the receptors for this type of equilibrium. So now that you know where the ampulla is, you can better understand how they work. On this picture, which is found on page 592 of your book, the white thing is going to be the crista ampullaris. And on the base of it, you can see these little pink projections. Those are going to be the cilia from the hair cells. So they're going to pretty much be our receptors. And how this works is that when you turn your head really fast or you spin, you're going to create an angular acceleration. And this rotational movement, it's going to pretty much create inertia that pushes the liquid inside the semicircular canals to shift from side to side depending on where you're rotating. And this motion is going to bend the ampullary cupula, which is in turn going to bend the hair cells, it's going to bend the cilia on the hair cells, sending action potentials down the vestibular nerves. And then these vestibular nerves are going to join the cochlear nerve, forming the vestibulocochlear nerve. It is also important to understand that balance is not only influenced from the sensory input from our ears, but also the sensory input from our vision and the muscle spindle fibers. If you remember, the muscle spindle fibers, they sense the stretching in the muscles, and this can help you adjust a little bit your posture, especially when you are in static equilibrium. Now, the visual input is actually very important for balance. This is the reason why, for example, dancers are told to spot when they're spinning so that they not only not get dizzy but also don't lose balance. And if you want to try it for yourself, close your eyes and try balancing on one foot. It's going to be a lot harder than it would be if you had your eyes open, and this is because we relied a lot on our eyes for balance. Well, thank you guys so much for the ones that watch this. I know it's pretty much one more thing that you have to do if you want to do it. This is not necessary, but if you want to do it, then it's just 10 more minutes of your day that you have to spend doing something when you could be studying. But I promise this is going to be a little bit helpful if you were a little bit lost. And I will hope to see you on Monday to discuss the things that you've watched on the video and any other question you have from chapter 15 or any other chapter really. And we will do the review on all the chapters on Monday. And I'll probably have the 1 hour and a half session instead of just the 40 minutes, because since it's your final, I feel like you will need a little bit more time to discuss all the material.